Hello and welcome back to the fourth part of the tutorial series in which we will be creating a in-game clock. Now in this video we will be adding our text display for our time as well as a clock, so a watch. And we will also be creating these buttons for testing purposes. So let's start with the text display. For that, we of course will need a sort of display, so we need a canvas. And we will create a empty child object. Actually, this will be not a empty child object, but an image. And we will call it date time display. And as a child of that, we will add a text. This will be the date time text. Now we can set the text to stretch to the parent and change the color of the display image to something darker, like that. Can change it to 22222, like that. And of course make it a bit bigger, like 480, I think 400, maybe 440 is enough, and the height 120. We will also set the canvas scaler mode to scale with screen size. Before we forget that, and set the alignment of our text to be center on both. Now the format we will be using in this tutorial is like the following. So we have year, then a number, then this downward slash. Then we have our month, so summer for example, and then the day. And in a new line, we will, inside of these brackets, have the time. So something like that. And let's also, do we need a dash? I think we can leave it like that. So that's the format we will use. But currently we have no way of getting the string easily. So let's add inside of our TimeState script a public string get date. And this will return an interpolated string. So return, then a $sign and parentheses. And we need the year, then the month, and then the day. We also need a public string get time, and we could write it like so. First the hour, colon, minute. So let's change this to the same format. And then we have a public string get date time. And this will just call get date, then add a new line, so /n, \n, and then we need get time. And we can also override the toString method and let it return the getDateTime. And to test that, we can go to our TimeManager, and every time our timer ended, we can just debug.log internal time.getDateTime, or we can just call internal time because we have overridden our toString, so this will return the date time. If we now hit play, we should see, yes, the time will be updated every second, but it's also very ugly. So if normally we would have 2 digits for the hours and the minutes at minimum, and I'd like to have the days and our year count also have 2 digits. We could write toString and then use D2 as the format for 2 digits, but Visual Studio already suggests that this can be simplified. And we can write it this way, which is way shorter and easier to read, because it just says, hey, we have the year, and look, that's the format we want to use. So let's do that for all of our integers. And if we now hit play, yep, this looks way better. So now we need a reference to our TimeManager, but for that we need the script for our display. So TimeState time display. Open that one up. And first we will need our TextMesh Pro. So private TextMesh Pro UGUI. For that we need the using TM Pro. And this will be called TextDateTime. Now in the wake, we will set TextDateTime equal to getComponent in children, TextMesh Pro UGUI. And then we need a reference to our TimeState. So this will be a private TimeState. But we currently have no way of getting that TimeState because this field is private. So what we can do is create a public static TimeState and call it current time. Now we can create a private void init for initialize, and inside of it set the current time equal to internal time. And to avoid changing the current time outside of the script, we can also give it a private getter, a public getter, but a private setter, like so. And now let's call the initialize function from here. One problem with this approach currently is that we could have 2 time managers and the second one would override the first time state. That's definitely something we do not want to happen. So what we can do is we can create a private static time manager and call it instance. And inside of initialize, we will check if the instance is not null And if it is not null, this means we basically already have a time manager. So we will set, we will destroy this game object, and then we will return. And if it is null, we will skip that part and just set the instance equal to this, and don't destroy, unload this game object. And now we should be good to go. We can now set our time state equal to TimeManager.currentTime. But right now we have no way of getting the time consistently through our time state. So what we can do in here is add a public event system.action that has a time state as a type, and we will call it OnTimeChanged. Now this will be invoked every time we increase or decrease the time, so we could also just call it inside of our update state. Invoke this. And now we can subscribe to that event. So OnTimeChanged plus equals TimeState OnTimeChanged. I will set that to current time. And now we can set the text date time dot text equal to current time dot get date time. If we now add this script, we should get an error when we hit play. Actually, we don't. That's because I already set up the time manager in here. If we were not to do that, inside of our script execution order, we would get an error. Yeah, like so. At first, because the time manager awake was called after the awake of our time state was called. So this means we don't have a reference. And the fix for that is, come on. For some reason, Unity froze for a moment. What's going on? Now it's working again. For that reason, we need to add our time manager in here to ensure this awake method gets called first. Let's see. This time, this error should not pop up. And indeed, it does not. And the time will be updated accordingly. So if we change our time on our time manager to some big number, this will update. Let's just remove one digit here. That's better. So now let's add our buttons for testing. We add a group, and I will call it control button group. And this will have a vertical layout group. Let's get this out of the way. And let's scale this up a bit, like so. 1000 by 400, or maybe 600 should be fine. Let's also get that a little bit lower. We can now create a new, actually a new image, and call it time control group, and we will later on make this a prefab. So we have two buttons in here. First is the decrease button, so button minus. The second is the increase button, so button plus. And we also need a label. Let's put that in between here. We can now set the control child size width to true, and add in here a horizontal layout group to our time control group. We want to control the height, and I think that it, yeah, we then want a padding on top and for the bottom. And we want to center it to the middle. Let's also change the color to something a little bit more dark, like so, and center the label as well. And I think we also want to make it a little bit bigger, maybe 400, like so. We will now make that a prefab. So inside of our assets folder, create a folder prefabs and drag it on there. We can now rename that to minutes group and change the label to minutes plus 10. Let's now add the script for, or before we add the script, let's change the text of our buttons. So one will be minus, the other one will be plus. Font size of 40 and bold. Now we can add our script. And I will call it time modifier button. Yeah. Now we need the references to our buttons. So first to private serialized field. We have to add serialized field so we can see it in the inspector, but we will set it private because we don't need it from any other script. So private button, and for that we need the using Unity engine.ui, a private button decrease, and a button increase. I will also add a header so it's easier to read. We have our buttons. And in awake, we first want to get our time state again. So private time state. TimeState is equal to TimeManager dot current time, and then times, we don't need anything else. Now we want to check if any of the buttons are missing. So if button decrease equals null or button increase equals null, we want a debug.log error saying some buttons are missing button references are missing, and the context is the game object. Then we want to return, so do nothing else. And if both are present, we want to set button decrease on click, add listener, and we want a lambda expression in here through which we will set our time. The problem is, if we now want to set the time, we can decrease time by minutes, but then we somehow had to hard code those values. So first of all, we need a serialized field, private int time. But now we always have the time in minute format. So we had to calculate for the hours how many minutes that would be, and input it in this field in the inspector. So I can show you that. On here, let's just add the time modifier button. Yeah, we just have this time, and we can't really say we just want 1 hour now. We would have to put in 60. So what we can do is make the factor type public as well as the get factor. So let's do that. Public and public. And then in here, we can add a TimeConverter dot factor type and call it time type. And then in here, we can just set decrease the time by minutes of TimeConverter dot get factor of the time type multiplied by our time. Let's add a header here and call it setting. And let's repeat that for our increase. So increase, and we also don't want any negative time values, so let's add a minimum of 1. There we go. Default will be 1 minute. And we can now also assign the buttons for decreasing and increasing our time. And duplicate that. We now have the hours group. Days and months. day, no, first hours plus 0, 1. Days plus 0, 1. And our month. Now all we need to do is change the setting. So here we want 10 minutes. On here we want 1 hour, 1 day, and 1 month. If we now hit play, you can see the buttons working. Cool. So all that's left for this tutorial is creating the watch we have here. So let's do that. For that, we will need a circle. So first, let's create an image. And I will call it watch. Let's get that to the side. Minus 280. And let's get that up here. So this will be minus 80, actually something like 160 and minus 160, minus 80. And we will set that to a circle. I will just use the knob sprite and increase the scale. That looks really ugly. But there we go. We want a circle. Let's assign that. That looks better. Let's do 280 by 280. And now we also need two handles. And if I recall correctly, I used the input field background image. So let's use that. We want another image. Minute and input field background. Color will be black. Width of 8 and height of 120. And what I did is change the pivot. I have set it to 0.04. Then change the position again, like so. And if we now start rotating along the z-axis, this will rotate around that point. We can actually see the exact point here. This will be the point around which we will be rotating the image. We now also need our hour hand, and the height will be 80, I think. Something's wrong here. Oh, yeah, that looks fine to me. So now we need a script that changes the hour hands. So let's create a C# script and call it watch display. We first need a reference to the hands. So this will be a serialized field, private transform minute hand, and of course the hour hand. Let me have a look. Yes, right. We also need a private float target rotation for the hour as well as for the minute. And we also need some values for determining how fast we want to get to the value. So private float lerp speed, and let's just add a range of 1 to 10. Now in onEnable, we want the TimeManager, current TimeState. So first let's get the private TimeState, and now in onEnable we will set TimeManager or TimeState equal to TimeManager.currentTime.OnTimeChanged. No. And then we want to set TimeState.TimeChanged. Set that to current time. And we of course want to unsubscribe from the event in onDisable. So TimeManager, TimeState dot OnTimeChanged minus equals that one. And we now need a update method as well as a update hands method. And we will call update hands from update. Then we also need a void handle hand. This will take the transform of a hand as well as the target rotation. And last but not least, we need a private void get rotation. Rotation TimeState state and out float hour rotation. as well as outfloat minute rotation. Come on. There we go. Now inside of our current time state, we want to get the rotation of the current time and set the target hour and minute by the out parameters. Now in here we can set the hour equal to state dot hour and minute equal to state dot minute, and after that we will calculate our rotation. So our rotation is equal to 360 degrees. So 360, that's the full circle, divided by the hours we have on a watch, so 12 times hour. And for the minute rotation, we also want 360, so full circle divided by 60, the amount of minutes we have for 1 hour. So now all we have to do is do our handle hand and update hands, and then we are ready to test it out. So if hand is null, we of course want to return to avoid any errors. Then we want to get the rotation. So rotation z is equal to math dot lerp angle. Come on. Then we want to lerp between the current angles, so rotation dot Euler angles dot z, the target rotation, and our lerp speed multiplied by time dot delta time. And we also want our hand dot rotation updated, so quaternion dot Euler 0f 0f, and then our rotation z. Now in update hands, we just have to call handle hand and our hand, and then minus our target rotation hour. And you will see in just a minute why we need to do that. Let's first test that out. We will add the script, apply the minute and hour hand, set this to 1. And something's not working. I probably forgot something somewhere. Target rotation minute. Oh yeah. Now it's working. Can increase the speed, like so. I like to leave it between 5 and 10. Let's just use 10 for now. but there's one problem, and that's that the hour hand doesn't move until we reach the next hour. And we can fix that by getting the minute. So all we need to do is add 360 divided by 12 divided by 60 times the minute. And there we go. We can see the hour hand does move with it. Let's change that back to 10. So it looks a bit better. And yes. So why do we need a negative target rotation hour? If we get once we get our rotation, we divide by some number. So we have in here it's a positive number, because hour will always be positive and minute will be positive, and all of those are positive. But what we actually want to do is, we want a negative rotation. So yeah, that's why we have to pass in the negative result of what we got here, and this will just lurk between the current negative rotation and the target negative rotation. So that's all for this video. It was a really long video, but I hope it was helpful, and you now have the basics of how to display the time and change the time from other scripts. And I will see you in the next video, in which we'll be creating our custom inspector. So this here looks like we have it here on our TimeManager, like so. I will see you then.